Hi guys, welcome back. And this is Nagaraj SK, lecturer of Computer Science and Engineering Department, Jain Polytechnic, Belagavi. So, in this session, we'll move to the next lecture, that is lecture number 24 and 25 of Unit 3, that is brute force and exhaustive search. So, here I'm going to cover bubble sort of brute force approach and sequential search. These are the two topics I'm going to cover in this video. So let me begin with the bubble sort, brute force bubble sort. So what a bubble sort is? It is an sorting algorithm. So it is another simplest sorting algorithm. In bubble sort, largest element is moved at the highest index in the array, and as the largest element moves to the highest index position, it is called that element is bubbled up from its position. That is the reason the name is given like bubble sort. So in the next pass, the second largest element bubbles up, then the third largest element bubbles up, and so on. After n minus 1 passes, the list gets sorted. The pass the pass I, that is a bubble sort, can be represented by the uh, following diagram, that is a of 0 to az, then less than or less than greater than a of I j plus 1, then a of n minus I minus 1, and a of n minus I less than or equal to, and if those many elements are there, that is a of n minus 1 elements are there in that. So till the last position, all the elements will be bubbles up for sorting by applying this bubble sort algorithm. So next we have, that is brute force bubble sort, that is we have here particular algorithm for that bubble sort. So in this we have a method by the name bubble sort itself. It is taking an argument, that is an array of argument it is taking, then an array as an argument it is taking. So for I equal to 0 to n minus 2, do this. Then for j equal to 0 to n minus 2 minus I, do the following, that is if a of j plus 1 less than a of j, then swap the elements, that is swap swap a of I and a of j plus 1. Then what about 89, 45, 68, 90, 29, and 34 and 17? These are the elements we have. So the complexity is like something like of n, which is belonging to theta of n square, and the worst case complexity of these n elements is c of n. So can you improve it? Yes, we can improve it with the help of sequential search. So what is the sequential search? If you want, before going to the sequential search, so I'll move to the I'll go back to the bubble sort algorithm itself. So we have an example here: 89, 45, 68, 90, 29, right? So I'll just take these 89, 45, 68, and 29. So first it will get compared with 89 and 45, then 89 and 68, then 89 and 90, then 90 and 29. So in the second pass, what happened? 45 is smaller than 89, so that 45 will bubbled up and comes to the first position, and 68 and 29 will be compared again. 68 will be there at the same place, and 45, 89, then 29, then 90. So 45, 68, then 89, 29, and 90. Then 45, 68, 89, again we will compare. 89 will be compared with 29, then 45, the list will become 45, 68, 29, 89 and 90, because 89 is the largest one compared to 29. Compared to 29 it is bigger than that, so 29 will come to the second position and 89 will go to the third position. So in the third pass what happens, 45, 68, then again 29, then 89, 90. So here 45 is smaller than 68, that is fine. Then 68 is greater than 29, so the 29 will come to the first position and 68 will go to the second position. So in the fourth pass 45 and 29 will be compared, and 29 will come to the first index, then 45 will go to the second index, then 68, 89, 90. The list is sorted. So this is how this bubble sort algorithm will work. So next we have here sequential search. What is sequential search, right? In this method, the element to be searched is considered as a key element. Then each successive element is compared with the key element. If the match is found, then it is called successful search, otherwise it is unsuccessful search. So we have here the sequential search algorithm. It is also taking an array as an argument plus a key which is used to search that particular key element. So what output we are going to expect is index of the first element in A, that is array A, whose values is equal to k or minus 1 if no such element is found, whose value is equal to k or minus 1 if no such element is found in the list. So if I equal to 0, if I, and what input we are going to give, right? So here input we are giving an array A of n elements and a search key k. Those are the two arguments we are passing to this algorithm. So I equal to 0, then while I less than n and a of I not equal to k, do this. What we have to do, I equal to I plus 1. If I is less than n, then return the value of I, and else return value as minus 1. That is input size equal to n, and the basic operation we are making use in this algorithm is less than and not equal to, and the worst case complexity of this algorithm is 2n plus 2. And now we have brute force, can you improve it, right? So that is the question I'm going to ask you people. Now we have brute force, can you improve it? So here, if you knew A to be sorted in non-decreasing order, could you improve the search? So in the compared to previous slide here, just a minute, just a minute. So this is the basic sequential search. So can you improve it with the help of brute force? So here what we are doing, we are improving that with the help of brute force approach. So here A of n is initialized by the key element k, then I equal to 0, then while a of I not equal to k, that is key element, do I equal to I plus 1. Then if I less than n, return I, else return minus 1. Input size is n, basic operation is only not equal to, there is no other operation we are doing like less than we were doing in the previous without using brute force. So here the worst case complexity of this algorithm will become n plus 2. Previously it was 2n plus 2, right? So if you knew A to be sorted in non-decreasing order, could you improve the search? Yes, we can improve. So that is the final question. I'm leaving it to you people, so please go through this video once again and judge that particular algorithm, how it works, how these two algorithms works, that is bubble sort and Sequential search. So let us summarize what we discussed so far. We saw the brute force approach to sorting, that is, just solve it and improve it later. Then brute force to searching. Then how could you search for a key k in an array a of 0 to n minus 1? So these are all the things we discussed so far. So if you are having any doubts in this, please do ask your queries, and thanks for watching.